Okay, so today we are going to talk about the math class. Now, the math class is a class in Java, which we're going to talk a lot more about how classes and objects work in the grade 12 course. But for now, all that you need to know is that a class is a section of code that exists in the background of Java that somebody else created. Now, this class has a number of methods which you can access, which can help you in your day-to-day coding life. The math class allows you to do things like take the absolute value of a number, take the power of a number and do exponents, find the maximum or minimum, take the square root of a number. And one of the most common uses of the math class is that it allows you to make random numbers. And random numbers are extremely important when you are coding because when you're creating any sort of game, the idea of randomization is what makes a game appealing, right? That's what allows the user to feel like there's replay value in your game. So you're going to be using that a lot. Now, we're just going to go over a couple examples of what you can use the math class for. Starting over here on the screen, you can see that I create three integers, num1, num2, and num3, which start at -3, 2, and 4, respectively. So the very first method that I'm going to access through the math class is capital M math in order to access the class .abs for the absolute value. So what this is going to do is it's going to take the absolute value of a number or a variable, which as we all know, we'll just take if it was negative and make it positive. And if it already is positive, it's going to stay the same. So we say over here the absolute value of num1 is math.abs, and then the argument in brackets is num1. So if I run this, you'll see that the absolute value of -3 is +3. Now don't be mistaken, this does not replace the variable num1 with +3. It just temporarily creates +3 with this method, and then we print it out. If you wanted to replace num1 with its positive counterpart with its absolute value, you would have to do something like num1 equals math.abs num1 in order to reassign it with its own absolute value. All right. Um, Now, the second application that we are going to look at for the math class is how to take the exponent of a number. All right, because if you're trying to raise something to the power of 2, that's pretty easy to do without using exponents. If you're trying to do 5 to the power of 2, you can just go into Java and you can say, yep, 5 to the power of 2 is just 5 times 5, I'm good to go. But if you're trying to do something like 5 to the power of 18, you're not going to write 5 times 5 times 5 times 5 18 times when you're coding. That's excessive. That's when something like math.pow would come into play. For example, if I wanted to do 2 to the power of 4, I might use math.pow, and it has two arguments. What happens here is you take the first argument, and that's going to be your base, and you're going to take the second argument, and that's going to become your exponent. So this is going to be num2, which is 2, to the power of num3, which is 4. Okay, 2 to the power of 4 is probably 16. So we're going to run that, and we're going to see that 2 to the power of 4 is 16. Note that math.pow will automatically make its response. It will return a double, even if you put in two integers. So keep that in mind because that might come with some issues if you try to maybe take that and shove it into a integer variable, perhaps. Okay? You would need to cast it to be an integer first. So just keep in mind that math.pow will always give you the answer in double form. Okay, the next one that we are going to go over is the maximum value. So math.max can take two numbers as its arguments, and it will simply return the number that is larger between the two. So for example, math.max between num1, which is -3, and num2, which is +2, the maximum of those two numbers is going to be the number +2. So this would output the maximum between -3 and 2 is +2. Pretty straightforward. The exact same thing works for minimum. Okay, the minimum between num1 and num2. The minimum between -3 and +2 is -3. You just use capital M math dot min for that, and then the two numbers as your arguments. Okay, the next one, which is also pretty straightforward, is math dot square root. It simply takes the square root of the number, which is the argument. Over here, our number is 4. So it'll tell us that the square root of 4 is going to be 2. And again, this returns it as a double, so the square root of 4 would be 2.0. All right, if you wanted that to be an integer, you would simply cast it to be an integer, as we learned back in the first or second unit, and 2 will become not 2.0, but the integer 2. Okay, now those should all be pretty straightforward. You can look under the math class for a lot of different options. If you just type in math and then dot, it will pop up with all of the options that you have from the math class that might help you, right? So for example, we have math.pi here, which gives you many digits of pi if you ever need it. And so you don't have to write all those out. You have the absolute value, add exact, you have sine and tan that you can calculate. You have cosine over here that you can calculate. You have the floor, which will take the lower value. So take a moment, you have logarithms in here, look at that. Take a moment to go through all of these if you feel like you need some mathematical function that you might want to access. Okay, you even have significant digits over here that you can work with if you ever wanted to use science. Okay, now one of the most common ways that you will be using the math class, as I briefly mentioned at the beginning of the lesson, is to create random numbers. All right, and this is also the area that's easiest to make errors, so please make sure that you are using proper syntax when creating random numbers. Now, the key word to create a random, or the key line of code to create a random number, is capital M math dot random. All right, and technically what this does, although you don't need to know it, you just need to know how to work with it. Technically what math.random does is it creates a random number between 0 and 1, right? A random decimal. Okay, and what we're going to do is we're going to multiply that decimal by 10, and that simulates the idea of giving us a random number between 0 and 9. But here's what you need to know. When you are creating a random number, you are going to take math.random and you are going to multiply it by what you want the upper bound to be. And I'll give you an exact equation for this in a second. Okay? After doing that, you need to take this whole bracket and you need to cast it to be an integer because it's going to give you some kind of crazy decimal. And 99% of the time when you're creating a random number, you don't want it to be a decimal. You want it to be, I don't know, either 0 or 1 if you're flipping a coin, or a number between 0 and 10. What this line of code does is it creates a random number between 0 and 9. And I'll explain exactly how that works in a second. Okay, so if I run this, a random number between 0 and 9 is 0, 9, 2, 7, 7. You can see that as I keep clicking it, we keep getting random numbers. It is never less than 0. It is never more than 9. Okay. Now, comparatively, this second line of code is a little bit different. I have this exact same chunk, math.random times 10, which used to pick a random number between 0 and 9, but I am now adding 20 to it. This is going to pick a random integer between 20 and 29, and I'm sure you are seeing the trend here, but I'll explain it clearly in a second. So this right here will pick a random number between 20 and, oops, we'll pick a random number between 20 and 29, as we can see with the output. Now, how exactly does this work? All that you need to know is you need to know how to calculate the lower bound, which in this case is 20, and the upper bound, which in this case is 29. Now, I'm going to give you a brief equation on how to figure out the lower and upper bound when you are creating random numbers. So let me just get out my pen here. Now, looking at this more complicated line of code down here, we have 20, which we will call A, and we have 10, which we will call B. Now, the equation for the lower bound, which is the minimum number that we can pick, is A. Okay, pretty straightforward. As you can see down here, the lowest number that we could pick was 20, which is A. Over here, the lowest number that we could pick was 0, which we can imagine that we're adding 0, to this equation, it would be the exact same thing. But we don't have to write 0 because 0 plus anything is itself. It's redundant. So the lower bound is going to be A, and if you do not see A, that means that A is 0. Now the upper bound is going to depend on B, which is the number in the brackets. Okay, the equation is going to be A plus B minus 1. So over here, it would be 0, which is A, plus 10, which is B, minus 1. So 0 plus 10 minus 1 is 9, which would be the upper bound, giving us a range between 0, which is A, and 9, which is A plus B minus 1. Down here, minimum bound A, which is 20, and upper bound 20 plus 10 minus 1, which is 29, giving us a range between 20 and 29. So as long as you know these two equations up here for the lower and the upper bound, and as long as you know the syntax, which is that some variable which you want to place the random number into is equal to math.random times b plus a, and then you were going to cast that to be an integer afterwards. So make sure you're practicing with this, because this is definitely where we're going to see all of the errors for this lesson, is creating random numbers and making sure you're creating exactly the random number that you would like to create. So let's do one more random number down here, because sometimes we want to include negatives. So what's going to happen here is we have negative 50 plus math.random times 101. So if A is equal to negative 50 and B is equal to 101, that makes our lower bound negative 50, the minimum number that we can pick, and our upper bound is equal to negative 50 plus 101 minus 1, which is going to be equal to 100. Okay, so our lower bound is negative 50, our upper bound is 100. So that means we're picking a random number between negative and positive 50. So again, if I am taking this code and I am running it, you can see over here in the bottom, 37, negative 9, negative 4, etc., etc. Okay, so please make sure you keep that in mind, because you will be using random numbers a lot. Now let me show you an actual application of random numbers. Over here I have a guessing game which I will first run, and then we will look at the code. I strongly recommend that you guys recreate this program before starting your homework. So I am thinking of a number between 1 and 10. Okay, as you can guess in my code, I made a random number. Can you guess it? I will give you 3 tries. So what is your guess? Oops. Is it 8? No. Is it 5? No. Is it 3? Luckily enough, I got it on my 3rd try. It was the number 3. But if I got it wrong all 3 times, then the program would just end. It would never say that I was correct. So how exactly does this run? Well, let's take a look at the code. I create a scanner for the user input. I create a variable, which I'm going to take the user input as the guess, and I'm going to put it in there. And then I'm going to create a counter which keeps track of the number of guesses that the user has used so far. I am going to create an answer that I want the user to guess. This answer will be a random number between 1 and 10, as you guys should know this line of code creates. I print out the instructions, pick a number between 1 and 10. You have 3 guesses. Now, I have a do while loop, which I'm going to use to take the user input and compare it with the correct answer. This do while loop will repeat 3 times. And it will leave immediately if they guess correctly, because if they guess correctly, I don't want to tell them to guess again. So I prompt the user for their guess. I take it and put it inside of guess number. I then take the guess number and compare it to the correct number. If they're the same number, I say, hey, your answer was correct. Congratulations. And we use break. We immediately leave the do while loop. Okay, because we don't want them to guess anymore. If it is not correct, so if this returns as false, then we will enter the else statement where we will simply say that's not correct. We will increase the counter by 1 because that is one less guess that they have, and we will do the whole thing again. So I strongly challenge you guys to create this exact program. After doing so, adjust this program so that instead of 3 guesses, they get, I think I have the instructions down here. Perfect. So adjust this program so that they are creating a random number between 1 and 50 instead of 1 and 10. Give the user 5 guesses instead of 3. And instead of just saying right or wrong, tell them your guess was too high or your guess was too low to kind of give them more information to get closer and closer to the correct answer, right? And that allows the user to be in more control over the game. So those are your 2 tasks. Please make sure that you practice those because it will help you get used to creating random numbers and applying them in interesting ways. Okay, make sure you're completing all your homework and let me know if you have any questions.